A series of powerful successive earthquakes struck the Turkish-Syrian border on February 6. The first and most powerful was a 7.8 magnitude quake. Destruction followed as aftershocks hit the region. Then, a 7.5 magnitude quake hit in the afternoon, followed by its own series of aftershocks. In the wake, a humanitarian and economic crisis. Thousands of people are reported dead and even more are still missing. It's not the first time this region has suffered a violent quake, and it won't be the last. To understand why, you have to look under the surface where three tectonic plates converge. Together, these plates cause a unique and potentially devastating type of earthquake. The first quake was located here, 17 kilometers under the town of Gaziantep. 17 kilometers may sound deep, but that's actually shallow for a major quake. The town is especially vulnerable because it sits near the meeting of two tectonic plates. Tectonic plates are massive slabs of rock on the Earth's crust from 16 kilometers to 260 kilometers thick that are always slowly moving. This one is called the Anatolia tectonic plate. It's actually a microplate due to its tiny size and is constantly under pressure. That's because it's being pressed upward against the Eurasia plate by the Arabia plate. That pressure is squeezing the Anatolia plate westward, where it faces even more friction from the Africa plate, which is also moving upward. That means that the boundaries between the Anatolia plate and the Africa and Arabia plates are trying to slide against each other as Anatolia moves to the west and the African and Arabia move to the east. These borders are called strike-slip faults, and when the friction builds up between the plates and they're pushing different directions until it's too much, they slip. That's a strike-slip earthquake. That's what happened in Gaziantep, resulting in that 7.8 magnitude quake. USGS estimates that the strike-slip occurred along about 160 kilometers of the fault, about 32 kilometers shorter than the most strike-slip earthquakes. Experts say the energy released in the slip is comparable to that released during the explosive 1980 Mount St. Helens volcanic eruption. The same thing happened 8 hours later in Ekinozu, resulting in a 7.8 magnitude quake. This one was just 10 kilometers down. More than 285 aftershocks have followed both quakes. USGS has called the area tectonically active and unstable. Those complex tectonics are responsible for a long history of devastating quakes like this quake from 1966 that killed over 2,000 people. The 965-kilometer North Anatolian fault produced 7 large strike-slip earthquakes from 1939 to 1999, and 3 earthquakes of magnitude 6 or larger have occurred within 250 kilometers of Monday's earthquake since 1970, but there hasn't been a large earthquake since 1999. That 1999 quake was a 7.4 magnitude and caused an estimated 17,000 deaths. For now, USGS estimates there could be billions in economic losses. But will there be more disruption if the 2 quakes spark a third? Experts are unsure, but due to the 3-plate convergence, it's not a question of if there will be another earthquake, it's a question of when.